So, in this video we discuss critical points and inflection points. First of all, let's recall that critical points are points at which the first derivative of a function is 0, and they come in a variety of flavors. So along each of these curves, there's one point at which the tangent line is horizontal. And here's another point at which the tangent line is horizontal, and here's another one right here. This is a local maximum. We can understand that fact by noting that as we move along the positive x direction, first we're going uphill, we reach the top of the hill, and then we're coming back down again. So if we write down the sign of the first derivative, it changes from positive to 0 to negative. And this is an indication that we're coming close to a point of this sort. On the other hand, if we're close to a local minimum, then first we're going downhill, we get to the bottom of the hill, and then we emerge back up again as we move along the positive x-axis. So the sequence of signs here are negative, 0, and positive. Next to points of this sort, which we call saddles, the slope is positive, then 0, and then positive yet again. And so we have the sign of the first derivative changing from positive to 0 to positive, and similarly here it changes from negative to 0 to negative. We've seen that we can represent this behavior also by the second derivative that tells us something about changes in the first derivative. Now, this change signifies that f prime x decreases in this direction, and that tells us that the second derivative will be negative throughout this region, and we associate that with the concavity of the graph. Namely, we see that for this case, the graph will be concave down. So the second derivative being negative indicates that we have a local maximum when f prime of x equals 0. This sequence from negative to 0 to positive tells us that f prime x is increasing, and that tells us that its derivative is positive. We see that that is associated with a graph which is concave up. In places of this sort, we have a local minimum. We observe that these two criteria, checking whether the second derivative is negative or positive, allows us to distinguish between these two. In this case, the second derivative may actually be 0 at that point, and in fact, right at the change in concavity, the second derivative will be 0 at the inflection point, and similarly here as well.